recording. All right. So happy Friday. You made it. Everyone else didn't. That's okay. Yeah, we've got that surprise no school on Monday. You guys all know that, right? Okay, good. I don't teach on Mondays, so I feel kind of like cheated in a way. I have every Monday off, but I'm like, I want a day off. Anyways, it's just how it is. All right. So just a smidge of review. There's only one main thing that I want to bring up from yesterday, and then we'll just keep going. I keep kind of tempting you with, oh yeah, I'll show you how to do it in R. Oh, for sure, I'm going to show you how to do it in R. And then I run out of time. So I'll show you how to do it in R next week. Just really quickly. I think I posted the R code if you're interested. But there's a couple of things that it took a little bit longer to get through than I had hoped. All right, so where we left off yesterday was to describe a distribution. All right, so to describe a distribution, oops. We need to talk about three things, right? So we need to talk about the shape, we need to talk about the center, and we need to talk about the spread. And so we looked at that. The shape, oh, helps if I put an A in there. So the shape is either normal or non-normal. Right. On an assignment, I'm going to get you to specify, so not just non-normal, but is it skewed to the left? Is it skewed to the right? Right, because we need to be able to look at distributions and be able to identify them. But in terms of classifying to figure out what the best center and spread are, then we just need normal or non-normal. Okay, and just as a heads up, I think on the assignment, I haven't posted it yet, but the question that I thought, oh, I should probably tell them that. If you have a distribution that looks basically like this is a uniform distribution, kind of obvious, but just in case you're curious, okay? I think you would probably pick that option, but just in case it comes up. Okay. I'm going to delete that though.
But uniform means normal?
Uniform means it's all the same, right? And so a normal distribution looks like this, right? And then a uniform distribution looks like this, or maybe something like that, where it's just all are the same height. But I'll delete that. All right. So then we looked at center and spread, right? Those were the three things that we needed to fully describe a distribution, right? So, we just eyeballed this, right? The center and the spread in terms, if we had a histogram, we'd be able to look at where's most of the data and what's a plausible range, right? But today we're going to talk about, we're going to have numerical measures of center and spread, of course. So we will have numerical measures of center and spread. So that's kind of where we got to last day. So I'll put a little end of review. Okay. So depending on the shape that we have, right, whether it's normal or non-normal, we'll stick to that. That's going to tell us what the appropriate center and spread are. Okay. And so I'm going to make a little table here with normal and non-normal. Those are the shapes, right? And the center and the spread. I'll kind of put those over here. Question? No. All right, so if we have a normal distribution, we established last day that we should be using the mean as the center, right? And so the mean, which we already talked about, which is denoted by X bar, right? That's going to be the most appropriate measure of center. Can't remember if I mentioned it, but of course, software or even just hand calculations, right? We're going to be able to find the mean of a non-normal distribution, but it's not appropriate. It's not an appropriate measure of center, right? And so that's what we're kind of getting at here. We'll be able to calculate all these things for any set of data, right? But it's our job to know as humans, it's our job to know that, okay, well, the mean is really only appropriate if I have a normal distribution. And then I'm going to use the standard deviation, which we use a lowercase s, right, to denote the standard deviation. That's the sample standard deviation, of course. And that's going to be our spread. Okay. So the mean and the standard deviation, they're buddies and they hang out all the time. And so if you're using the mean, you're going to use the standard deviation and vice versa, right? And same with the non-normal distributions, but then we're going to have to use what we call the median. Okay. The median is sometimes denoted, that wasn't a very nice tilde, but sometimes denoted by an X with a tilde over top. I don't use that notation. I just write median. So, because otherwise it's too many X's with stuff on top, right? And so, I don't use this notation though. I just write median. And we'll talk about what the median is, of course, but for now, let's just know that the median is the measure of center if we have a non-normal distribution. For the spread, we're going to use something called the interquartile range, which of course we have to talk about as well. But for now, wait. It's the interquartile range, which we usually just abbreviate IQR. So remember, a normal distribution, oh, that wasn't a very nice normal distribution. I don't need that y-axis. How about that? So if we have a normal distribution, right, then what we're going to find is that the mean is in the center, right? The center is where most of the data is located. And so it's not being pulled in any direction, okay? And so that's why we can use the mean and the standard deviation. The problem with a non-normal distribution, so if we have something like this distribution is skewed to the left, right? So now all of a sudden, what we're going to find, questions? What we're going to find is that the mean would be pulled in the direction of the outliers. right? And so if we just have a quick example like 2, 6, 7, and 9, and then I ask you to find the average of those, right? That's fine, you could do that. But what if I changed it? So what if I changed this number to -20? I'm still divided by 4. It doesn't change the number of values, right? But now all of a sudden my sum is going to be shifted towards that -20, right? And so what we find is that the mean, right, the average that we're talking about, the average is always pulled towards outliers. Okay? And maybe I'll just kind of lump this over here, right? The mean will be pulled towards outliers. Okay. Another way that we could say that is that it's not robust to outliers, right? Robust is like strong and kind of steadfast, right? And so, so we call it robust. So it's not a robust measurements. So measurement. The mean is not robust to outliers. Okay. Because in this situation, right here, there are no outliers. The mean is kind of pulled evenly in the center, so that's nice. Whereas here we've got these outliers in the tail, right? So then the mean would be pulled in the direction of the tail. So it's no longer useful as a measure of center, right? And so then we introduce the median, and the median is robust to outliers, and same with the interquartile range. Okay. The median and IQR, interquartile range, are robust to outliers, right? And so that's why we use them as measures of center and spread for non-normal distributions. Okay. I didn't really write anything about this example, but hopefully that kind of made sense. Okay. All right, so what I want to do is, we've already talked about the mean last day, right? And so today I want to go through the rest of these, and so we'll start and we'll talk about the standard deviation. We're not going to do an example, but I am going to outline the steps of how you would do it, because then I want to show you how to use R to do it. And honestly, you could just find a standard deviation calculator online somewhere. There's lots of free ones. And then you can just use that if you wanted to, right? So we don't have to do it by hand, but I do want to walk you through the formula. And then I want to talk about the median. How do we find it? By hand. And same with the interquartile range. Okay, so that's kind of where we're going. All right, so let's start with the standard deviation. The standard deviation we denote by a lowercase s. And I'm going to write out the formula so that we have it, and then we're going to dissect it. Okay. So it's going to be the sum, and I'll play it all cool, but then I'll put the indices on there. The sum of x minus x bar squared divided by n minus 1, and then take the square root of all that. Technically, each of these x's, there's x1, x2, x3, x4. So really what I'm saying is do this for each of the x's. So there should be an xi here, and I need some room here. The sum from I equals 1 to n. Those are technically supposed to be there, but usually I drop them because I get lazy. Yeah. This formula, if it's been a while since you looked at mathematical formulas, it's not very nice looking, right? And so what I want to do is I would just want to build it out from the inside out. And that's how we always approach formulas, right? As we work from the inside out. Okay. I'll try to use different colors, but if we go kind of to the inside, we kind of go as deep as we can, right? Where we land is this xi minus x bar, right? If we had to kind of guess what's that saying? Well, it means that we're going to need x bar, which is the mean of x, right? So we know how to find that. We know how to find the average. And from each observation, we're going to subtract the mean, right? And so what we call this the deviation, right? It's the deviation from the mean. How far is each observation from the mean, right? From the center. So I'll call this step 1. From each observation, subtract the mean. I guess there was a step 0, find the mean, but let's assume that you have that already, right? Okay. And so here I'll just make a note that we call this the deviation, right? Which is where the name standard deviation comes from, of course, right? And if you think about it as a measure of spread, well, what are we interested? What's the spread? Well, the spread from the center, right? And so that's exactly the root of this calculation, right? Is just finding, well, how far are all these things from the center? The problem is, if we were just to add up these deviations, how the mean is calculated, the sum of these would add to 0, right? Just because some of them would be negative and some of them would be positive, and then you add them all up and all of a sudden you're at 0. Okay? And that's always going to be the case because that's just how the average works. Okay? So then if you have this be 0, right? Everything squared is 0, right? And then you sum those, you're still at 0, and then divide by something, 0. It doesn't get you anywhere, right? And so to get around that, right, we need a way to make these values positive, these deviations positive, right? You might think the absolute value is a good option, right? That makes negative things positive, right? And that is an option, and that is something that we could do, but, and it is a measure of spread, but it's not the most common one, right? So the most common one is squaring the values, okay? So when we square values, right, negative values become positive, positive values stay positive, but it has that added benefit of amplifying larger distances, right? So if you think about a deviation of 1, for example, right, 1 squared is just 1, right? But then if I double that deviation, puts me at 2, right? But then 2 squared is 4. So all of a sudden that deviation is amplified, right? And so that's what we want. We want to kind of be penalized for larger deviations. And so that's why squaring it is the way to go, right? Or the way we do it, or the most common way to do it. And that's the standard deviation. Okay, so the next thing that we do here, I don't know how familiar you guys are with sigma notation, summation notation. Fun to say, fun to do. I feel like if I just keep saying that, you guys are going to think it's fun eventually. It is fun to say, so check. Because there are no brackets following the summation, it's implied that you're summing everything after it, right? If it didn't want you to sum everything after it, you'd have to break it up by brackets, right? You'd have to put brackets around the summation and then square it, for example, right? But hopefully that's okay. So the second step here is you have to square each of the values, right? So you're going to have from each observation, you're going to subtract the mean, right? And then, so now you can, usually if I have to do by hand, I start with my original data set and then I make a new column with each of the observations minus the mean. And then I make a new column where I square each of them, right? So however you want to do it. So then I want to square each of the values from step 1. Now, like I said, we're not going to go through an example because it is quite time consuming. But what I encourage you to do is on the assignment, there's going to be some pretty short data sets that you can practice with. You're welcome to use a standard deviation calculator or R or whatever you want to check your work, right? But just try it to make sure that you've got it under control. Right? One thing I will say is that usually when we calculate by hand, the mean, if it has, you know, a ton of decimal places, usually we round to 2 or 3 decimal places. So then when we round a value, all of a sudden our answers are just slightly different from what software would give us. And that's totally fine, right? Just slightly different. Just something to be aware of. Yeah. All right. So here, next step, we're just building out, right? We are now going to work on the sum. So now I have a list of values. They're all positive because I've squared them all, right? And so now we're going to find the sum of the values from step 2. So now I have a sum, and that's just going to be one value, and that one value is what I'm going to divide by n minus 1. Now the n minus 1, we probably want it to be n, but if I just beg you to just accept it for what it is, it's just n minus 1. That's just how it is. Hopefully you're okay with that, right? It goes back to things like degrees of freedom and the fact that you've already used an estimate in here, so you have to take one away, but you don't need to worry about that as long as you're okay with it just being n minus 1. Okay. So here, divide the sum. In the end, it really is just because it gives us a better estimate than dividing by n does. Divide the sum by n minus 1. Or I guess I should say the sum from 3 by n minus 1. And then finally, I'll use red because this is the part that people forget about all the time. And I get these frantic texts late at night saying, my assignment doesn't work. It doesn't work. I can't find this. I don't know what's going on. But usually it's because they've forgotten to take the square root. So don't forget to take that square root. Square root the value. This is, of course, just one of the formulas that we could use. There's lots of other formulas that do the same thing. They've just been reworked, right? But I like this one because it highlights that it's the distance between the observations and the mean, which is kind of at the core of this thing. Spread. Okay. Any questions about the standard deviation? All right. Then let's talk about the median. So the median is the value that splits our data in half, right? So we have the lowest 50% below it and the highest 50% above it. Okay? And so the median is the value. Remember, the median is a measure of center, right? So it's the middle value is the value that splits our data in half. So 50% below it and 50% above. So if you want to have a data point with 50% below it and 50% above it, kind of goes without saying that you need to sort your data first, right? So let's see here. To find the median, we first need to sort our data. I'll highlight that. And I should clarify from smallest to largest, but I think that should go without saying, from smallest to largest. In theory, you could do largest to smallest, but I don't think our brains work that way, so I don't do that. Okay. So for this, I have an example that I wanted to grab from kind of my old notes, and I know it's cheating here, but you don't need to read this blurb. We're going to be looking at GDP for a set of countries. Okay, so that's going to be our data, and I'm going to bring it in here. Okay, so here we have this GDP data. Wait, from some years, doesn't matter, whatever. This is numerical data, right? That's a good start. Okay. And next week, I'll show you the histogram of this, so how to bring up the histogram and stuff like that. But for now, we're going to use this data as an example. And of course, you could calculate the average. I trust that you're all capable, right? And you could even calculate the standard deviation, although it'd be a little bit of work, right? But I always like tedious work. If it gets kind of tedious, then I know what I'm doing and it feels good, right? So I like tedious work, but a lot of people don't. Anyways, so if we're going to find the median of the GDP data, right? First thing we want to do is we want to sort this data, right? To find the median, we first sort the data. It's going to be really helpful if we know how many data points we have, because you don't want to lose any as you go. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'll just make a note here. N equals 12. All right, my sample size is 12. Okay, now, like Martha Stewart, I have them all prepped here already. So, but what I encourage you to do is, as you use up a number, I would cross it off, right? Just to make sure that you've got it, because you don't want to muck that up. And so step 1, sort the data. .9, 3.2, 3.9, and here 2.9. I'll cross them off now. 3.2, 3.9, 4.1. Should do them properly. 4.4, 4.6, 4.7, 5.2, 5.4, 6.2, 7.3, not sure what happened there, but that's okay. And 9.4. Once you've got them all sorted, that's great. I want you to just double count again, right? Make sure that you still have 12. Otherwise, it'll mess everything up. You'll see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, good. All right. So once we've sorted the data, then the next thing we're going to do, and technology, right? So I'm just going to steal this and copy it and paste it below. I know you can't do that, so give yourself kind of more room if you need to. So the second step, to find the central value here, the midpoint, I use my my patent pending boop, boop, boop method. I just take my fingers and I boop, 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 boop my way in. It's crazy, but it works. There are formulas that you can use, but the formulas really only give you the location of the median. It doesn't give you the value of the median. So then you would still have to count in. Seems weird. So I just boop, boop, boop my way in. So then count in from both sides to find the central value. To find the central value. So I'm gonna boop, 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 boop. I like to kind of pause, do the other side, because when I'm drawing it, it's hard. But usually if I'm doing it on the page, I kind of go cross-eyed, so boop, 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 boop. But anyways, so I did 3 boops, boop, 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 boop. Uh-oh, now what? Okay, so if I land on 2 values at the same time, what do? Well, it seems weird because we're finding the median, but then I take the mean of those 2 values. That's weird. But that's how we do it. Okay. And to show that that's what I'm doing, I draw a circle around those 2, and then I draw a line down the center. Okay. And then I say that the median is 4.6 plus 4.7 divided by 2, 4.65. Nice. Good. So finding the median is just kind of fun. One thing that I will say is that if you're using R, you might get slightly different values because it uses a more sophisticated technique than just finding the average, right? So on that note, the assignment questions and the quiz questions assume that you're doing it by hand like this. Okay, so you can double check your answers using software, but it does assume that you're using the boop, boop, boop method. Okay. So I do want to write that note down here. Maybe I'll write a little note here. Okay. If using software, or maybe I'll just say, if using R to find the median, it will use a more sophisticated weighting method than just the average. It will use a more sophisticated weighting method than taking the average. Okay. Assignments and quizzes assume that you're doing it by hand, right? So not using software. Assignments and quizzes assume you are finding the values by hand. So that's probably good to keep in mind. Okay. Okay. So that's how you find the median. Okay. I will show you what happens if you do land on a value, but before I do that, I want to show you how to find the quartiles. Now, if the median splits the data in half, then I think that you could probably get there if I say, okay, well, the quartiles split the data into quarters, right? So the first quartile is going to split the data into the first quarter of the data, right? And then the median is the second quartile, and then the third quartile, 75% below it, 25% above it, right? So it's just splitting the data further into little pieces. So the quartiles, split the data into quarters. We use Q subscript 1 for the first quartile. Which has 25% of data below it, 75% above. All right, if we think about quarters, the median is usually what I call it, but the median is Q subscript 2, right? Q2 is the second quartile. I'll never call it that, but it's nice to kind of remember that they're the same. Okay. The second quartile, 50% below, 50% above. And then Q3, the third quartile, has 75% below and 25% above. These are special percentiles. I don't work so much with percentiles. I really only care about these, right? But a percentile has p% below it and 100 minus p% above it, right? So maybe I'll write a note here. These are special percentiles where the pth percentile, so the 75th percentile, for example, is Q3, right? Where the pth percentile has p% below it and 100 minus p% above it. But I rarely talk about percentiles, but especially if you're, you know, talking about kind of growth data and stuff like that, you'll be talking about percentiles, but it's good to know that what they are, but software will just calculate it for you. Okay. So we've got these special percentiles that we call quartiles. Okay. And how do we find them? All right. Well, it's not that crazy. What we do is now we focus on the lower half, and I basically find the median of the lower half, and that's going to split it into quarters. And then I look at the upper half of my data, right? Based off of where my median is, I can look at the upper half, I can split that in half, and then all of a sudden I have these quarters. So let me grab this. Okay. One thing to note, and I'll show you the alternative after this, here, the median is between these two values, right? So when I draw this line here, I haven't used either of these values as the median, okay? So that means I'm allowed to use it to find the quartiles, okay? And so here, if I go and find the first quartile, right? Boop, 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 boop. And again, I'm stuck between two values. That's okay, because now we know what to do, right? Q1 is 3.9 plus 4.1 divided by 2, which is 4.0. In general, you should match the number of decimal places that are given at least, right? Sometimes we do a couple more, but at least match what's given. Okay. So that's your first quartile. Okay. What if we do the same thing to find the third quartile? Well, not that crazy. Boop, 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 boop. And maybe I'll draw this one up here. Q3 is 5.4 plus 6.2 divided by 2. And I get, well, I don't get it. Someone in my previous class got 5.8. I had to ask for it. Come on, anyone? Okay. So, is it 5.8?
Yeah.
Because I just took their word for it. I never checked it, not even when I got back to my office. Oh yeah, that's what it is. Okay, nice. So that's how you find it. It's pretty fun once you kind of get the hang of it, right? And so just to have a look and see why these measurements are robust to outliers, right? I haven't formally introduced the interquartile range, but I think you're kind of on to me now that we have two quartiles. Inter means between, right? The distance between the two quartiles. Well, that's what we're going to use, but let's just kind of sit on that for a little bit. But why are these robust to outliers? Well, let's think about this. If I change this 9.4 to 940, right? My mean would be just pulled way towards 940, right? But the median and the quartiles, they don't care if this is 940 or 9.4, right? They just see, okay, 1 value, 2 values, 3 values. And so that's what makes it robust to outliers. So the median, and I'll say, and the quartiles, are robust to outliers since we could change 9.4. For example, I usually manipulate the last one because it's easier. In the data set, to be 940, and the median and the quartiles would not change. And the median and quartiles would not change. What happens if I kind of gray out this 9.4? So we're going to ditch that 9.4 altogether. And I know I'm out of time. Sort of. Sort of. Right. Now, if I don't have that 9.4 anymore, then I start over and I want to find the median. Boop, 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 boop. Now 4.6 is the median. So now I cannot use it to find the quartiles anymore. So my quartiles have to start at the 4.4 and 4.7. So that's the difference here. Boop, 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 boop. 3.9. It's a lot easier when you land on a number, right? But I had to start with a harder one and go for it. Boop, 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 boop. Q3 is 5.4. Step away from the plate. All right. We'll pick up there. Right, but that's the general idea. All right, if you have any questions, let me know. Otherwise, have an awesome weekend. We'll see you on Tuesday.
Emily,
yes?
why are we learning to do this in manual? What's the philosophy behind it?
Part of the old school curriculum.
Got it.
Yeah. I'll stop the recording, but